Chapter 7, Systems of Equations and Inequalities. We're going to start with Section 1, Linear and Nonlinear Systems of Equations. So, what we're looking at is applications where a problem or a scenario has many equations that govern it that you have to adhere to, and you want to find however many solutions to those equations there are. So, for example, it could be a system with a lot of lines, and where do those lines meet up? Could be a system of a line and something that isn't a line. So then where do those meet up as well? Where are the solutions to those systems? So where do the lines or equations intersect? How do we find those? Particularly, how do we find them without a graphing calculator? So how do we find them algebraically? So when you solve one equation, you're finding the solution to that equation. If you're finding multiple solutions to multiple equations, you're solving a system of equations. So no longer one equation, but a system or a number of equations. So for example, a system with two equations with two unknowns, do 2x plus y equals 5. So there's one equation, and then 3x minus 2y equals 4. So when do these equations meet each other? What solution, an x and y coordinate, would satisfy both of these equations? So we're still looking for solutions that satisfy both equations. This is going all the way back to chapter 1. Given an x and y coordinate, could you plug that coordinate into the equation to yield a true result? And you have a solution of an equation. If that coordinate yields a true result in more than one equation, in both or multiple equations in the same system, you have a solution to the system of equations. So that's when we find all solutions. We are solving this system. So there are multiple ways to solve a system of equations. We're going to look at one of them right now. This one is particularly beneficial for systems of linear and nonlinear. So if you have a linear equation and you have something else, quadratic, cubic, whatever, substitution is a pretty good method to solve that system. So let's keep working with this equation, this system of equations we have. 2x plus y equals 5 and 3x minus 2y equals 4. So we'll scroll down a little, and we'll keep using that system, and we'll solve it. So make sure I write down correctly. 2x plus y equals 5. Or 3x minus 2y equals 4. Okay. Now when using the method of substitution, you want to take one equation, solve for one of the variables, and then plug that solution into the other equation. When you substitute, when you plug into the other equation, you are writing a new equation with only one variable. If there's only one variable, it's pretty easy to solve, just algebra 1 skills. So you have two equations, and you want to take one of them and solve for one of the variables. Preferably, one of the variables in one of the equations that doesn't have any coefficients on it. That's a pretty easy variable to solve for. So of these two equations, get the different color, it makes sense to solve the first equation for the y variable. So take your first equation, bring it down, and we want to solve for y, so get y by itself. So subtract the 2x over, y equals 5 minus 2x, and then that quantity plug into the other equation for y. Make sure you plug it into the other equation, not into the same one again. Plug it into the other. So that expression, 5 minus 2x, plug it into the other equation for y, and you'll get, kind of done with my detour now, go back to black, so 3x minus 2 times that quantity, 5 minus 2x. So minus 2 times y, now minus 2 times what y is equal to. So 5 minus 2x equals 4. And then solve just like you know how to. So distribute the -2, 3x minus 10, -2 times -2 plus 4x. So minus 10 plus 4x equals 4. Combine like terms, 3x and 4x is 7x. Add the 10 over, get 14. And x equals 2. So now we have a numeric value for x. Take that numeric value. Now you can plug it into either equation for x. So I'll do the first one, because why not? So 2 times 2 plus y equals 5. 4 plus y equals 5, y equals 1. So I have my ordered pair solution of 2, 1. So parentheses 2, 1. And writing it as an ordered pair is what you will see a lot of the time. If you want to keep it labeled, so x equals 2, y equals 1, you can do that also, just make a list, either way. So method of substitution, getting your ordered pair, take one equation, solve for one of the variables, and then plug it into the other equation. So we took the first, solved for y, got our expression, and plugged that expression into the other equation for y. So I believe on the next page are some more examples you want to look at. You want to solve those and then check your answers with my complete notes online.